What's up, everybody? In this video, we are going to look at how to display the weather data on a web page. The web page will run locally on the Arduino. The weather data will be fetched to the Arduino by making an API call to OpenWeather. I want to start off by examining another piece of example code for the Wi-Fi S3 library. In the previous lessons, when we looked at connecting to a web page on the Arduino, we took an input from a web page and controlled an output on the Arduino. We can also take an input from the Arduino and display it as an output on a web page. In the Arduino IDE, click File, Examples, Wi-Fi S3, Wi-Fi Web Server. This will open a piece of code that connects to a router and hosts a website on the Arduino. When someone loads the web page, it displays the values of pins A0 through A5. Let's upload the code to the Arduino to see it working. Ensure you have entered the SSID and password in the Arduino secrets file and click Upload. Once it is done, open a web browser at the IP listed. You should see each analog input listed and a value. If you wait, you will see that the web page automatically refreshes and provides new values. You might be wondering, why are there analog values showing up if there's nothing plugged into the Arduino? This is a phenomenon called floating inputs. When an analog pin is left unconnected, floating, it acts like an antenna and picks up electrical noise from the environment, from things like radio frequencies, static electricity, and power supply fluctuations. While the floating inputs isn't really that important for what we want to achieve, there is another action that is. In the code, adjust the delay function to 10,000. Re-upload the code, and you will see that the Arduino refreshes the data every 10 seconds. The delay changes how often the data is refreshed. Anytime you work with an API or any sort of system where you're tracking data, how often you refresh the data is something to consider. If you make too many API calls by trying to refresh your data too often, this can flood the API and get you blocked from making requests. If you don't make enough calls, your data will be old and out of date. How often you do this depends on the system you are creating and the type of data you have. Let's see if we can combine this sketch with our OpenWeather API sketch. Let's use AI to help us code this. Copy the Wi-Fi web server code. Open your Select AI and paste the code into the prompt window. Next, add the following prompt. Combine the following Arduino sketches. Make a website where the Arduino connects to a local network. From a browser, someone can access a website on the Arduino that displays the weather. Paste the code from the Get Weather Arduino sketch we created in an earlier lesson and click the Submit button. Copy the generated code and paste into a new Arduino sketch. Click on the three dots in the right-hand corner and click New Tab. Enter Arduino_.hsecrets and click OK. Click on the Arduino Secrets tab and enter the SSID, password, and API key. Click on the Code tab. Upload your code to the Arduino and ensure the serial monitor is open. When the Arduino has connected to the router and displays an IP address, open the address in a browser. You should see the weather conditions with temperature, humidity, and conditions. Cool. The website will update every 5 minutes. There's one small issue. There's an A with a circumflex showing up in the temperature. Let's find out why. Reply with, when the temperature is displayed, the character A with a circumflex is also showing. Can you remove this? The A with a circumflex is appearing because of an encoding issue. Copy the new code and upload it. When you test it out, it works. Awesome. If you want, you can continue to work with the AI to add additional features or make the page look nicer. At the end of this video, you should be able to create a website that updates using external API data.